Hi, I'm Shane. Welcome to my shop. Welcome to my channel. This video serves as an update to the last video. If you didn't see it, go check it out. It's about helical gear cutting for gear for a Walker Turner bandsaw. And I didn't get too far. I haven't had a lot of time. I've been super busy at work, and I apologize for not updating a video sooner. But I've got to do it now. So in the last installment, I got all set up to check my numbers for my lead angle on my horizontal mill, and I had a piece break. So in the last couple weeks, I did have a chance to make another piece, and I got a piece of stock for a gear blank, and I set up and checked my lead on the mill with an indicator. I'll show you a clip of that later. We'll get to it. I'll go over a little bit. I didn't get a whole lot of video, but I did get some footage of making the spline shaft. Actually, this one that's sheared. So I did make that, and I got set up, and I have the appropriate cutter, which a lot of that we determined in the last video. If that last one was a little confusing, I've really tried to simplify it. It's a lot to simplify, but basically, apart from the finding the correct cutter, the diametral pitch, all those components of the gear, we found the lead angle, and basically the lead angle is the trigonomic functions of a triangle wrapped around a cylinder. Let's see how far it would have to travel. That tangent angle would have to travel going around the cylinder to come back to 360 degrees from where it started. So that's basically that. Feel free to watch that video and all the math there. It's also should be in your machinery's handbook, or the information literature's out there. But hopefully that last one simplified it enough where it's just a little more easy to wrap your head around. That was the goal. Moving forward, I guess I'll flip you around, and I'll show you what I got going on and the updates on that, and I'll show you a couple clips of cutting the spline shaft and then checking the gear and what that's going to entail to actually cut the gear. So hang tight. Alright, so this is the shaft that broke, and I thought that maybe I screwed up, but I think it was just ready to give up the ghost, because it's the one that I had made is set up just the same, and it's working fine. Actually, I mean, you'll be the judge of it later. I'll show you the video. I just used a piece of bronze, and I took it over here through my door to my finished bay. I used the oversized super spacer on the undersized Bridgeport mill, and basically, after cutting a blank, turning down the outside diameter, to this diameter, and the inside diameter to this diameter, outside diameter, inside. This is a nominal size 5/8, and the shaft that it rides on is 3/1000 under, so it was perfect to just drill and ream. And then break the edges, just break the corners so it's, finished. Machine work stuff. Then I put that piece in the super spacer with a 12 position disc, and basically just found the center of the shaft, and I stepped it over half the width of the tooth and half the width of the cutter. So I could cut the one square side, and then I moved it over the width of the cutter and the width of the spline tooth to cut the other side, skipping every other because this is a 6-spline shaft. So I would skip a position so that I was only using 6 of them, and then I centered it back up and used the other 6 that I was alternating past to cut the centers. And that worked pretty good. Everything fit good, it went in the mill good, and it's working good. Other than that, excuse the mess, I've been moving a lot of stuff around. I also have this piece of 8620, which just happened to be the cheapest piece that I could find to make a gear blank, but it's suitable for gear making. It's not a real hard metal, but it doesn't really have to be, because what I pulled out wasn't hardened anyways. It's just cast iron. You could file it. So yeah, we have to make this main blank out of that. I'll perform the undercut here. I have to figure out what these diameters are, because this one's a little critical. And then I'll have to probably bore or drill and ream the main hole and cut a keyway in it. And then I have to make a mandrel, as I said in the last video. It's only a 1/2 inch wide, so I'll probably just use the chuck. I'll set it with an indicator, and it'll be perfectly fine for what we're doing. Yeah, so it's all working out. I just need to find time to make the pieces and do the work. I'll show you a clip now of this running across, the indicator running across the face of the tooth, right there on the top where the cutter's going to be. So I went ahead already and set up the dividing head. This is a 5-to-1 dividing head as opposed to your usual 40-to-1, like the Brown and Sharp style. So it's pretty easy to set up. I need 94 teeth, so I can just select a plate that has 94 holes. And since it's 5-to-1, I just skip 5 holes, and that's already set up to do that. The only real concern that I have is there's a little bit of slop in the gear train, like every other old machine. So what I'll probably end up doing, instead of tracking back through the gear to make the next cut, I'll probably have to lower the table and raise it back up 94 times, which is going to be fun. And then I'll, like I said in the last video, I'll check it with gauge pins or thread wires or something, just some kind of a constant, and make a secondary cut and do that again 94 times. So we get to do that at least a minimum of 188 times. Should be fun. But other than that, I think on the right track here, and hopefully, well, for sure, the next video about the helical gear cutting, I will get you some video clip of cutting a gear blank, possibly making a mandrel if I can't, find one, buy one, or steal one. And then yeah, I'll definitely have video footage of cutting a few teeth. I won't make you watch me cut 188 different times, but I'll get you some footage of cutting a few, and then final product, and hopefully fitment and running the Walker Turner bandsaw. because that'd be pretty cool. Okay. All right. Well, that should be about all for this video. Hopefully the next time you see me, I'll be finishing up a gear. Unless you want to talk about this cool little die filer that I just picked up. Pretty sweet for all your die filing needs, whatever that may be. But yeah, thanks for stopping by. Thanks for watching. Don't be afraid to hit the like. Don't be afraid to subscribe or share or whatever. If you like what you see, if you don't, comment. Either way, thumbs up, thumb down, I don't care. But I appreciate your time. I appreciate you watching.